Hello guys, welcome to my channel Click and Design, and in this video tutorial we are going to create a detailed drawing for this drive shaft. As you can see, we have a drive shaft model over here and it has a lot of interesting features, starting from this tapped hole over here and a slot in between. Then going on forward we have a undercut and one more slot for the woodruff key, and in the end we have a shaft end with threads, or you can say a stud. So to create the detailed drawing for this shaft, we need to orient this model in such a manner so that we can see maximum of the features for this shaft. So for that case, I will select the side view. In this side view, I can see maximum features like the lengths of different sections, the diameters, and so on. So without wasting any time, let's start with the drawing. For that, let's go to File, click Drawing from Part, and now you have to just select a sheet. Let's select A3 ANSI landscape sheet and click on OK. So here we have the sheet. On the right side in the view palette, we have this current view on the bottom. Just drag and drop this current view over here, and from the menu you can change the custom scale from 1:1 to let's say 2:1. Click on OK. So here we have this right scale for this view, and now I need to change my units to mm. So units have been changed. You have to refresh the view palette. Okay, so the side view is here for the shaft. Now first of all, as we know that this shaft is cylindrical in form, for that we have to go to annotation and create a center line for this shaft. So let's select this view. The center line has been created. Now click on OK. After creating the center line, we have to mention the different lengths of different sections. So we have different sections, so we have to mention the lengths. For that, let's go to Smart Dimension. First of all, let's start with this section over on the right. So here we have this length for this section. Now going on forward, this section also same. Now in this case, we are going to leave this section, and let's mention the length for this threaded end. So this we have different lengths. Now let's define the total length. So here we have the total length. Okay, now the reason why I left this length, because of many reasons, because when we are going to produce this shaft or to manufacture this shaft, we cannot get a desired length, okay, every time. So that's why I have left this length for the tolerance purposes, and here I can manage the length accordingly, according to the production method chosen and the type of production quality. Okay, so here we have the different lengths. Now we need to mention the different diameters of different sections. So starting with the first section over here, Smart Dimension, and let's select both the edges and place the diameter. Okay, in this case you can see here we have this section for the shaft, and also here we have a slot, and this section particularly will be used to fix some mechanical component. It can be a gear, it can be a pulley. So accordingly we need to specify some fit with tolerance for this particular section. As we have this diameter 36, select this diameter, and in the dimension, in the values, you will see tolerance position. In place of none, you have to select fit with tolerance. Then in place of user defined, as we know that we are going to fit a mechanical component over here, so that's why it should be a transitional fit. And as we know that it is a shaft, so in this case I'm going to select M6 fit. So just type M from your keyboard and you will have list of M fits. So let's select M6 and click on OK. So here we have this fit with tolerance for this particular section. Now going on forward, we have one more section over here, and this section will be used to on this section we are going to install a ball bearing. For that purposes, again we are going to use some fits. So let's select first of all the edges and place the edges, and here again in tolerance you have to select fit with tolerance. Here we have have this transitional fit. Again, in this shaft, we are for now the case is for the shaft, and for the inner surface of the ball bearing, we are going to select fit, that will be K6. So just K and 6, click on OK. So here we have two dimensions, two diameters. Now moving forward, we have this section over here, and this also have a slot for the Woodruff key, as you can see here inside. So accordingly, smart dimension, and let's define the dimension over here. In this case, I'm not placing the diameter over here because it can create a messy look for the drawing. So better let's place the dimension over here on the left side. Again, select the dimension, and the value you have to select in place of none, fit with tolerance, then transitional, and in shaft you have to select M. So here we have M6, click on OK. So here we have the fit with tolerance for this specific section. Now going on forward, we have this threaded surface. Here we have M30 thread, and the pitch of the thread is 1.25 mm. So let's do it. Smart dimension, let's select the edges and place it. Okay, now I will manually edit this text. For that, select the text, and in the dimension text just delete yes, and write over here M30 into 1.25. that is the, we have this thread over here, and also we can see we have a chamfer for the starting of the thread operation. So again, smart dimension, and place it on the top. Here we have 1.1, we can just make it 1 into 45 degrees, 45, and here we have the degree sign on the bottom. Select OK. So here we have the chamfer now. Okay, also we have undercut over here, so we need to make a detail view. For that, go to drawings, and we have detail view. Just create a detail view and place this view on the bottom. Let it be 5:1. So here we have this detail view. Okay, for that annotation, smart dimension, let's start with the inner edge. So here we have the inner diameter. Select the edge, and you can place the inner diameter, and similarly we have this outer edge. So select it, and you can easily specify the outer diameter for this. Now we need to specify the width of the undercut. For that, again, smart dimension, select the edges and place the width upwards. So here we have 2, and in 2 we are going to write 2 max, because we are not going more than 2 mm for this width. So here we have 2 max. Now we need to specify the angle of this undercut, because we should mention that how at which angle our tool should cut or should exit this threaded operation. So it is very much important. So smart dimension, select this edge and this one. Okay, here we have this angle, so at which our tool will be going to exit the undercut. So now, after placing the angle, we need to specify the 2 radius for this fillets, and I would like to tell you that both the radius have same value. So for that, we'll use smart dimension, and let's first of all specify the first radius value, that is 0.5. Select the dimension, go to liters, and here you have custom text position. Select the middle one, and now here you can select this middle one to make your this arrow in such a way inwards. And now we'll place the same arrow over here. So we need to multiply this leader. So just press Ctrl key from your keyboard, drag and drop the arrow to the place where you need it. Okay, so here we have radius value for these 2 undercuts, radius value for these 2 fillets inside. So we are done with this detail view. Now we have this slot over here, so we need to define the slot also. So for that I'm going to create a detail broken out section view. So for that I need to go to drawing, and here we have this broken out section. For that, first of all, I would like to create a spline, and here it is asking for the depth. So I would like to tell you the depth will be, we have the maximum diameter over here is 45, so the depth for this section will be 45 divided by 2, that is 22.5. and okay, so here you can see we have this slot for the woodruff key. And for this slot, first of all, what we will do, first of all we are going to we are going to select annotation, and here we have center mark. First of all, select the inner slot, and here you can see the center mark is very much extended and large. So just go to the properties, uncheck use document defaults, and uncheck extended lines. Okay, so here we have the center mark. Now we need to mention the position of this slot from this edge, taking this edge as the reference. For this we have the smart dimension. Again, select the edge and select the center mark, and here you go, here we have this dimension as the reference for this slot. Now also for this slot we need to define the radius value. For that, smart dimension again, and select the slot, and here we go, we have this radius value for this. So this is done. Now one thing more, we are not sure about the depth, about the width of this particular slot. For that we should create a section view. Again, drawing, and here you have section view. Just placed you should place the section view in the middle. Okay, and here we have this section. As this section is aligned to this shaft, we need to first of all unbreak the alignment. So here we have the alignment. For that, just right click on the view and go to alignment, break the alignment. Now just bring this alignment over here, and now select this view, and you can just change the scale. Let's make it 1:1, so I think it will be normal. So here we have this section. Okay, now in this case, first of all, let's go to annotation, and let's select center mark and select the view. Okay, so now let's go to sketch, select point, and let's place a point over here. Okay, smart dimension, select this point and select this bottom surface, click on OK. So now for this dimension I will be adding some tolerance value to this also. So select the dimension, and in place of none you have to select bilateral, and here you can just place some values, +2. Okay, so here we go. Now also for the width of this slot, let's place the dimension here. Again, also I would like to give some tolerance values to this. Let it be, so here we go. So I think we are done with this section. Now going on forward, we have one more undercut over here. So to do this also with the help of detail view, let's create a detail view over here, and let's place it somewhere here because we are lack of space. So okay, here we have the detail view, and now again the same trick. Go to annotation, smart dimension. Here you can specify the outer diameter, the inner diameter. Okay, and this one also. So okay, so actually we don't need this diameter, we can delete it. Okay, now again we have to specify the thickness of this slot, the width of this slot. So So now we need to define the width of this slot. For that, let's go to smart dimension again, select the bigger edge and the edge over here. Now again we need to now again for this undercut also we need to define the width of this undercut. For that we are going to use smart dimension, select the this bigger edge and this edge and place it the edge over here. Now you have this value 2 and you have to just add max also with this, because we should not exceed this limit or otherwise different lengths can vary. So here we go. Next we need to define the angle of the undercut. So smart dimension, select this edge and this one. So here we have this angle as 45 degrees over here. Now let's define the two radius values. So again smart dimension, and here we have the first value. Go to leaders, check custom text position, select the middle one. Okay, so here we go. And also you have to just make it inside this leader, and you have to multiply it. Press Ctrl from your keyboard, drag and drop the arrow like such. So here we go. We have this radius mentioned, the width is mentioned, and the diameters are there already. So here we have this undercut. As you can see in this undercut, this capital letter A, it is without the leader. So just select the letter A, and from the menu in the style you can select with leader. So now the leader is visible. Same goes for this undercut. For C, select with leader and click on OK. So this is done. Also we have this radius over here, so for that again smart dimension, and here we have this radius. Leader, text position in the middle, inside. Okay. So this radius has been defined. Now going on forward, first of all let's make some place over here. Let's manage to have all these views over here. Let's try, maybe we can succeed. Let's place it over here. Okay, and let's try to place this over here. Okay, so this problem is solved. Now we are left with this section only, and I would like to tell you that in this section we have this slot over here, and we have a tapped hole over here. So what we can do is we can create a broken section view for this. So let's do it. Draw, and we have broken out section. So let's create a spline so that we can see everything inside. Okay, again the depth will be the half of this maximum diameter, that will be 45 divided by 2, that will be 22.5. Check on preview to see inside. So you can see inside we have this slot and this tapped hole. Click on OK. So again now let's start with the hole first of all, and before going to hole let's mention this chamfer annotation, smart dimension, and let's define this chamfer. First of all, chamfer value, and 45. Okay, so the chamfer value has been mentioned. Now let's go forward for making dimensions. After placing the chamfer value, let's start with this tapped hole. First of all, we also have a chamfer over here, so, and we have this countersink detail over here. So let's start with this. First of all, let's go to smart dimension. Let's specify the diameter for this countersink, that is 9. Now we have this threads over here. Specify the threads, that is M8 into 1. 1 is the pitch for the threads over here. Okay, and going over next, we need to specify the depth of this countersink for that smart dimension. And here again 1 into 45 degrees. Okay, now going on forward, we have to specify the length of the threads. So smart dimension, so this edge and this edge, and place it downwards, so that is 16. So after specifying the length of the threads, we need to specify the length of the hole also. For that, again smart dimension, and this edge and the starting edge, and on the bottom here we have the length. So let's again make some adjustments. So after making the adjustments, also we need to specify the angle for this countersink smart dimension, and we have to select these two edges for this hole and specify the angle. Because we are out of space, so we need to manage all these dimensions. We need to just mention this angle in such a way so that minimum amount of mess should be there, so that all the dimensions should be placed accordingly without any problem. After placing this angle, the dimensioning part for this hole is complete. Now let's come on to this slot. This is the last feature left for this shaft. So as you can see, we can see the length of the slot, but we cannot see the radius of the slot. So we need top view for this particular feature. We'll go to drawing and we'll select auxiliary view, and here we'll select the bottom of this slot, and you can just place the view over here on the top. Click on OK. Now again we just need the slot part. So again for this purpose we have one more tool in the drawing, that is crop view. To make a crop view, first of all we have to create a spline boundary across this slot. For that, let's go to sketch, and here we have this spline. Let's make the spline about this slot. Click on OK, and after this you have to go to drawing, crop view. So here we have this slot, the top view for this shaft. Now we need to just bring it downwards over here, and let's place this over here, view D. You can see we have this arrow. You can see we have this arrow with letter D, and this is the view over here from that arrow. So for this slot, first of all we have to go to annotation, center mark, place the center mark, and for the slot we have to just select this option, click on OK. Now we need to define the radius values. For that, again annotation, smart dimension, and specify the radius value, leader, custom text position, and this one. Okay, so the radius of the slot I have mentioned. Now we need to define the length of this slot. For that purpose, again smart dimension, select both the semicircles and place the value over here. But in this case, if you want to mention the total length of the slot, you have to go to leaders over here, and in the bottom you will see the R condition. In the R condition, you have to simply select max on both the side and click on OK. So here we have defined the slot for this shaft. Also we need to define the depth of this slot. That again on intuition, smart dimension, and select the top edge and the bottom of this slot, and just place the dimension over here. Okay, and also let's go to leader, custom text position, middle one. Okay, so here we have the depth of this slot, and also let's give some tolerance values to this also. Select bilateral, and let's make it in such a way. So here we have mentioned the depth of the slot also. So after placing all the dimensions, we are left with only the surface finish. So let's place the surface finish signs or symbols for this particular detailed drawing. For that, let's go to drawing and let's go to annotation, and here we have surface finish. So let's first of all start with the thread. So here for the thread purpose, I would like to have a surface finish of 3.2. So let's make it 3.2 and let's place it over here, or you can just drag it in such a way that it not make any intersection with any of the dimension lines. After, let's go forward to this surface. So again here, let's select surface finish for this surface 3.2. Now moving on forward, for this surface I would like to have 1.6. So 1.6, let's place it over here. Now going on forward, for this particular surface, again I will apply 3.2. So here we go. We need to make some changes, little changes, and our drawing is ready almost. So let's confirm each and everything that we have described each and every feature or not. So here we have the threads, we have the details for the threads, the length of the thread also, undercut is done, this slot is done, section is done, radius is done, reference dimension is done, overall dimension is placed already, this undercut we have done already. Okay, this slot, it is done over here, and we have this tabbed hold, the dimensions are there already. Okay, and for the diameters of the sections, they are placed with the fits and tolerance. Okay, over here the views are complete. So I think now we are done with the detailed drawing for this drive shaft. If you liked the video, please hit like, share and subscribe to my channel. Thanks for watching.